So in this video, we're going to be discussing rotation, reflections, and translations. Now we've gone through all these before. We're going to just practice what we need to do. So in order to correctly perform a rotation, I need a point to rotate it around, and a direction, and an angle of rotation. So typically, especially as we begin, we tend to rotate around the origin. Eventually we may rotate around R, or maybe I'd have you rotate around another random point, but for this one, we'll just rotate around the origin. So as I was saying, we have that point, so we're going to go around the origin, and so we need to either go clockwise or counterclockwise, and I like to go counterclockwise, which is this direction. On the test, we point, we use the arrows, we do all those things, and the word. So this is, we're going to go counterclockwise, and that's that direction. And let's go ahead and go 90 degrees. Will be our angle. So this is our point, that's our direction, this is our angle. And so we're going to go ahead and move this triangle 90 degrees. So one of the things, like I've shown you before with this machine, is that I can do is that I can put my center of rotation anywhere. And so right here, this is my dot. This represents my center. And so this will automatically rotate, all these lovely things that are hooked together, lovely, around. And let me unlink those. Hook around this point, and I don't want to go around that point, but that's the idea. And so I'm going to go over here to the origin, make sure that's right there, probably up a little bit. It doesn't move like that, but anyway. And then grabbing this, I'm going to go counterclockwise, which is this way, 90 degrees. And that's 90 degrees right there. So let's just I want to show you what happened. So I can use patty paper as we've done before. Wait, that's R. And this is T, and this is S. I can use patty paper to ensure that I went 90 degrees, but the other thing I can do, this is a little weird, so bear with me, but if I draw from R to my point and then to the new R prime, I'm create a right angle. And if I were to continue that with each point, so from T to T prime, that's a right angle, and from S, light blue, from S to S, that's a right angle. We could measure all those with our papers and kind of figure that out, but each of those is a right angle, and it gets really messy. I felt like I couldn't really tell what was going on with S, so I'm just going to kind of back up. And yeah, now I can see the right angle. So I can use that to kind of see it, what's happening, and that's how I can verify that it's a rotation. But the patty paper really handles that for me, as I fold it into quarters and make sure that I'm moving it one turn, or if it's 180, 2 turns, and if it's 2, you know. And so if it's clockwise, it's the other direction, and that kind of thing. Let's move on to reflections. Now reflections, we can do lots of different things. We can reflect across any line. So I could reflect across that line, I could reflect across this line, I could reflect across this line. I need a line to reflect across, though. I can reflect across this line, and that's where it gets really tough. As far as this test is concerned, we kept it really simple so far. We'll get it harder later, but we need a line of reflection. So I'm going to do a reflection. I'm going to do 2 reflections. We're going to do the x-axis first, and we'll do that one in red, and then we'll do the y-axis here in blue. And so when I do the x-axis, which is going to be red, I notice that W is 2 spaces away from the x-axis, so W prime is 2 spaces away from the x-axis, but below instead of above. U is 3 spaces away. Notice that they're in a straight line. U prime will be 3 spaces below. V is 5 spaces above, V prime will be 5 spaces below, and there is my reflection across the x-axis. And I can use patty paper and flip and all those things, but the idea of just keeping everything straight lined up, when I say straight lined up, I mean like this, straight lined up, and equidistant, same distance away from the line of reflection. That's the idea there. So with the y-axis, which again I'm doing in blue, away from the y-axis, W is 1, U is 4 spaces away, and V is 3 spaces away. My height stays the same. The only difference being, of course, that I'm switching the line I'm doing. And so that is the basic idea. What's interesting to note is that if I took this red triangle and rotated it at 180 degrees, it would land on that blue triangle, which is pretty dang cool. So a double reflection is the same as a rotation. That is just a piece of information that doesn't matter, but that's the idea. Make sure you pay very close attention to which axes you're doing, and keep in mind that we will make it harder by going across much more complicated axes later. Then the last one we want to talk about is a translation. Now, translations are exceedingly simple, but in order to translate, I need to know how it's a slide, and we can move up or down and left or right, or we can do both at once. Now, we can't use left and right at once, but we can use move up and right, or down and right, or left and right. So that's what I mean by both. So I need to know how much. So I'm going to go ahead and move right, because there's not much left here. Move right, let's go 6 units, and down, because again, there's not much up, 4 units. So, let's put it in, yeah, blue's fine. So down 6, wait, excuse me, down 4, right 6, 4, 6, and there's K. Notice it's gone down 4 and right 6. So there's K. J down 4, right 6. M down 4, right 6. L down 4, right 6. And I'm out just a little. Sorry about that. But that's the idea. The shape that I create should be exactly the same as the original shape. But that is the basic idea of your basic transformations. I hope that you remember those and you're all getting ready and readier for the test tomorrow.